It won't run. It won't run because the right side of the work is too far to the limit of my machining area. All right, so we're here at the Precision Matthews 728V-T to do a little bit of work before I put it in the mill. I've got a little drawing here that I'll show you, and it'll explain what I'm going to drill in now, and just how this will work in preparation for holding this in the mill and then doing my 2 ops required to get this plate done. So the overall dimensions of the plate are 12 inches by 18 inches. It's 1045 steel, 1 inch thick. For this op, I'm going to be drilling these 2 mounting holes. These are the holes and counter bore that I'll use to mount it to the fly press when this is done. And then I'm also going to do a clearance hole, and might use this to indicate, these are all through holes by the way, but I'm going to drill here, remove some of this material right here. I've got a little through hole, 1 inch square, kind of a hardy hole for bottom dies that I have that use a square inch, 1 inch square shaft. And so I'm going to do 3 holes at 25/64 with a 1/2 inch counter bore, actually slightly bigger, 0.575 inch. So I'll counter bore with a 1/2 inch end mill, and I'll double check with the socket head or socket cap bolts that I'm using, and maybe that'll be enough, but if not, I'll probably end up chasing that with a whatever it's called to bring that out to the 575 thou that I need. Once I have these holes done, these will line up and register with a piece of aluminum. That'll be the next stage. I'm going to mill up some aluminum that I can bolt this to, and then the aluminum itself will interface with the 0-point fixture that I have in the mill by Silver CNC. It'll have the 4 retention studs in the aluminum. I can push the aluminum down or secure the aluminum, and this will go onto the big aluminum and hold fast. I'll do a top op to finish the hardy hole and to start my T-slots, and then I'll flip this plate in the mill and then finish up the T-slots, and then really get into and finish the milling I need for the guts of this flat press 0-point plate. .9. Shout out to Drill Doctor. I sharpened these bits before this op and it's cutting like butter. Cutting too well. Alright, before I go on, I've got my my hardware. This is 3/8/16 thread that I intend to use here. So let's just test. There's a tiny bit of play, but it fits. Now for the counter bore. I've got two counter bores. I got to go down 9.53 millimeters, and my final OD is supposed to be 14.61 inches or 0.57 inches, but since my end mill is only 0.5 inches, I think I'm going to take my bolts and I'm going to turn them down to just under 5 so they fit, and call it a day, and try, instead of trying to skim out another 75 thou, or yeah, we'll see how it goes. Alright, decided to go with the boring head instead of modifying the bolt. Let's see. Okay. Wonder if, oops. I'm gonna get this stuck in here. Okay. I think I need to go down a little bit more because it's sticking up just a little bit, but this will work. Go down a little bit more. I think what happens is, since the end mill is flat and this comes to a point, I think it's leaving a tiny bit of material here that's coming up, but that's okay. I'll take it down, you know, another millimeter, and then, I mean, it's not critical, and then that'll fit, and then move on to this one. Pretty good finish. It's actually my fast face mill. Okay, so this will be the bottom. This surface will be on the subplate here. And if I did it right, the retention knobs will fit in here. So I'm going to grab a retention knob and just make sure it fits in case I need to run another contour with wear to make it big enough. Perfect. Oh, perfect. Okay, so we'll check the thread depth. Yeah, alright, that's one and done. What the heck? That one's not good. I think that thread is foul. Okay, not too bad. change the tap. This is 3/8/16, not 10mm. It won't run. It won't run because the right side of the work is too far to the limit of my machining area. So I'll reprogram the face mill to go this way, and that should fix it. That noise. Okay, that noise is my Y-travel cover plates that covered the ways and the ball screws. I wasn't sure what that was because I usually don't face this direction, but it's working now. This is tapping with a partial retract. Tapping with chip brake, rather. Okay. Okay, so I'm not going to tighten these up just yet. I'm going to put an indicator in here, and I'm going to tram in this back plate. This is how I indicated it in the mill when I drilled out these holes. So that's how I'll also indicate it here. There should be just enough play. So I'll leave this one loose and keep this one a little tight. And once I get that trimmed in, you know, that's where the real fun begins. We'll start in the next video. I'm going to open up the two bores, the two holes here for the retention knobs. It's 16 millimeter ID, and I've gone with the industry standard size retention knobs for the 52 millimeter pattern. And then I'll also open up this 1-inch square for the hardy hole and start my T-slots, and then flip it, and then really get into the guts of the system. So, but that'll have to come in another video. I think I've got a lot of video footage, and I'm going to compile something and put this out as part 1. There'll probably be 3 parts to this. So yeah, that's where the fun starts. But yeah, so far so good. Nothing too catastrophic other than changing that face pattern from 0 to 90 degrees, so it would go this way. But anyway, if you stuck with me this long, thank you. Should be pretty interesting. I can see it in my head, so I'm pretty sure that I can bring it to reality. All right, thanks for tuning in. Thanks for watching. Take care. Bye.